Hey, it's Mr. Ng going over the Math 5 Chapter 2.1 test taken on February 7th, 2020. This is for versions H, E, and A. For multiple choice, circle the best answer. Find the remainder given the polynomial f of x equals 3x to the fourth plus 2x squared plus 5x, and we change that to a plus 1. And it tells us f of 3. So to find the remainder, you could do a couple of things. You could convert here, writing f of x over this, so f is the same, parentheses is the same, the x is different, therefore it's kind of telling you that your x value is 3. Now, another way to do the problem is you get subtracting 3, you get x minus 3 equals 0. Then you can use x minus 3 and use synthetic, or you can use long division. You could use x equals 3 for synthetic division, but here I'm going to actually, there's 3 ways, so then the last way I think is most efficient is the remainder theorem. The remainder theorem just says whatever your x value is 3, just put it into your equation. So every x value is 3 here. I get, I'm going to write this out, PEMDAS. And PEMDAS tells us how to simplify operations in order of operations, which means that you're not going to do multiplication, you're going to do exponents. 3 to the fourth power gives you 81. Let me double check that. Three to the fourth power is 81, and then you multiply that by 3 and you'll get 243. And then here 3 squared is 9, 9 times 2 is 18, negative 15, and then it's positive 1. So if you add all those numbers together, 243 plus 18 minus 15 plus 1, you will get answer of 247. The answer is D. Remember, if we kind of do a quick sketch of this polynomial, we know it's an even degree polynomial and it goes through positive 1. So mine looks something like this. Let me think about this really quick. And then we're saying that at x equals 3, the graph is somewhere up there. So that's, well, it should be way up there, 247. So 3 comma 247 is the order paired, so it's way up there. That's the remainder. Question number 2, factor completely. Okay, so the first things you should recognize is that this is a binomial. 1, 2, if you had your factoring flowchart, it would tell you to, number 1, could you add a 0x, or in this case a p. So let's see if I do that. You're adding this placeholder. Now, in this placeholder, now you have a trinomial, 1, 2, 3, and then if you can take half of 3, and this is the number, then you can actually factor this by Xbox method. Now let's just say you did the placeholder to be 1.5. You'll recognize that the problem is prime. So, which means you cannot use Xbox. So no Xbox. Why? Because you need an A, B, and C, and so both these conditions, half of the exponent is not 1.5. Okay, so now you're left with same thing, original problem, 8p to the third minus 1. There is no greatest common factor, but one thing you should recognize is that if it's a binomial, 1, 2, and you can take the cube root. The cube root means 3 identical numbers that multiply to be 8. Another way of saying that is something to the third power equals 8, so that would be 2. 2 to the third power equals 8, or 8, the cube root of 8 is 2. Now, put that in your calculator just to show you. Here I have a TI plus CE, so I'm going to go to the calculator commands are math, and then scroll down there to number 4, and you put in the number 8. and gives you 2. And then if you do the same thing for 1, 3 identicals that multiply to be 1 are 1. Now, the cube root of p to the third is just p, because p to the third power is p to the third power. What does this mean? Your a value is going to be 2p and your b value is going to be 1. Basically, you have a difference of cubes. So in this problem, my formula is always going to be the same with a's and b's. A, b, a squared, a, b, b squared. And then we talked about the SOAP. That's why I chose to teach high school, because you use SOAP. Same operation. Opposite of the negative is a positive, and AP always positive. And then you just do your substitution. A is 2p, B value is 1. A value, be careful here, is 2p. So essentially this is 2p squared, which is 4p squared. A times B, so AP times 1 is just, or 2p times 1 is just 2p. And then B squared is B value, 1 squared is just 1. So 2p minus 1, 4p squared plus 2p plus 1, the answer is A. Now, just a reminder that this trinomial here is prime. You cannot factor that again. Question C3, multiple choice. What is the result of dividing x cubed minus 9x plus 5 by x minus 3? Okay, number one thing that you should have seen is that they're missing a, right here, they're missing a 0x squared. You have to have all the terms. I call that a placeholder. You need the placeholder. I chose to use synthetic division. So now I'm just looking at the coefficients. I have 1, 0, negative 5, 9, and 5. And with x minus 3 setting equal to 0, you get a 0 of x equals 3. You're going to put the 0 up here. And then we talked about synthetic division, bring it down. The first one you always bring down, then multiply. 3 times 1 is 3, and then you add down, and do it again. Multiply, add down, multiply, add down. So this last term becomes your remainder. You take the remainder, put in the numerator, the top. Your factor goes in the denominator. And then going from right to left, this is a constant, which means it has no variable. Then you add an x and then another x, that'll become x squared. So your answer is going to be x squared plus 3x. 0 you don't have to write. 5 here is positive. That's why it's not choice D. And then you just have 5 over x minus 3. Question number 4. Well, 4 right here. Factor the polynomial t squared plus 8t plus 2t plus 16. You can do this problem in 2 ways. The first way you can use is your x box. Why you can use x box here? Sorry. This would be x box. This is factoring by grouping. GRB. P. You have 4 terms here. So you count 1, 2, 3, 4. And you put them in a Z in your box there. And then you just take out your greatest common factor. T, 8, T, and 2. And then your answer factoring that would just be T plus 8, T plus 2, which is letter choice D. Now, why can you use Xbox in this problem is because right here, not a trick, but you actually, you have like terms. So you can just add those together and get t squared plus 10t plus 16. And then you can just use your Xbox. A times C is 16. Your B value is 10. 2 numbers whose product or multiply is to be 16. And the same 2 numbers have a sum or add to be 10. That would be 8 and 2. So t plus 8 and t plus 2. This part will not always work with factoring by grouping because not always are like terms. Question number 5. Use the factor theorem to decide whether or not the second polynomial is a factor of the first. So cross off that part. That just says question number 22 that I took. And then Decide whether or not the second polynomial, so that would be, this is the second polynomial, blue, is a factor of the first. The first one is here in red. Okay, so they want us to know using the factor theorem. The factor theorem basically says if a remainder is equal to 0, then yes, a factor. Or if the opposite of that is if the remainder is not equal to 0, then not a factor. So that's essentially what the factor theorem is. So here I have x minus 3 is a factor. I want to set it equal to 0. Add 3, I get x equals 3. This is called a 0. With this 0, then I can do a couple of methods for the factor theorem. Again, just like the first problem, you can use synthetic division. You could use long division, and you'll get the same answer. I'm going to be using the remainder theorem to help us understand the factor theorem. Same thing, I'm going to put in 3 for every x value. 3 squared is 27. Remember not to do multiplying here. You have to do order of operations, exponents, so that would be 9. And then you can just multiply, so that would give you negative 45, because that's a negative 5 times 9, 33. And if you add all those together, you will get 0. So the answer is yes, it is a factor. Again, what does that look like visually? You have a negative 15, and then I need to go through there, so something like this. Odd degree polynomial, and behavior starts down, ends up, negative 15 y-intercept, and then this idea right here at 3, we would highlight that. So because it's going through the x-axis, that is a factor, or this 0 is a factor. And the last problem says simplify square root of negative 63 using the imaginary number I. The factors of 63 are negative 1, 9, and 7. The square root, two identical numbers that multiply to be 9, are 3. Square root of 7 is a prime, so, and then the square root of negative 1 is I. So this, you can multiply those, 3i times 7. Your answer is D. There were 6 multiple choice questions, so the front side was worth 12 points. All right, let's go on the back side now. Factor completely, and then extra credit if you can factor over the complex. So it just tells me to factor. I need to make sure I show all your work in box or answers. I have 4 terms here, 1, 2, 3, 4. That should be a giveaway. Let's try factoring by grouping. And to remember, I found it super helpful to write them in the form of a z here. So let's go ahead and do that. X cubed minus 2x squared plus 5x minus 10. And then I'm just going to take out the greatest common factor, so x squared, x, negative 2, and then 5. And then I can double check my answer, right? X times x squared is x cubed, negative 2 times x squared gives me negative 2x squared, x times 5 is 5x, negative 2 times 5 is negative 10. So my answer is going to be x minus 2, x squared plus 5. Let's find a color. How about red? Okay, so this is called factoring over the real, because all of these are real numbers. Now, if you wanted the extra credit, you would have to have done the x squared plus 5. So x squared plus 5 equals 0. And a complex just basically means you need one I in there. You could use a quadratic formula, a lot of work. X squared plus 0x plus 5 equals 0, and those are a, b, and c, and put it into the quadratic formula. Or you should just recognize this is a square root problem, so subtract 5, x squared equals negative 5. we're going to take the square root here. X equals, pay attention, you need both a plus and a minus, the square root of -5. And then the factors of -5 are the square root of -1 times the square root of 5. This one becomes plus or minus I, and then square root of 5 you cannot simplify. So your answer is x equals plus or minus I radical 5. There's a couple of reasons why this works. Let me show you guys the answer. So I'm just going to take x minus 2. And then remember you have x minus, and then you'll have one of these to be positive I radical 5. And then you do the negative I radical 5. And then to clean that up, your answer would just be x minus 2, x minus I radical 5, and x plus I radical 5. And this would be factored over the complex. And this makes sense because the fundamental theorem of algebra tells us the number of zeros based on the exponent. So this is a power of 3. 1, 2, 3. Now, this tells you there's one real, and then there's actually two imaginaries. How do I know that? Because if you solved over the complex, this is one real, and this is an imaginary, and this is an imaginary. So 1, 2, 3 zeros. So if you wanted the extra point, then you would have to have had this as your answer. Question number 8. Solve x squared plus 6x plus 18 using the quadratic formula. Now I gave you a hint. I could have just said solve and then, but it's telling you just use the quadratic formula. Now to use the quadratic formula, you just have to know it and write it down. And you guys could have just obviously wrote that down from your formula sheet. X equals negative b plus or minus the square root, long square root, b squared minus 4ac. All over long division bar 2 times a. Okay, my a value is 1. B value is 6, C is 18. So now I'm going to do my substitutions. B value is 6. Notice how I'm doing my substitution in parentheses there. And then 6 squared minus 4 times my A value is 1. C value is 18. All over 2 times 1. So first step, write down the formula, quadratic formula. Second step, substitute, and then lots of simplifying. Negative 6. 6 squared is 36. Negative 4 times 1 times 18. It's going to be negative 72. All over 2. Negative 6 plus or minus 36 minus 72. Put that in your calculator. Negative 36. All over 2. And then I'm going to write down the factors of negative 36, which is going to be negative 1 and 36. All over 2. Negative 6 plus or minus, okay, square root of negative 1, we've seen this throughout the, is I. Square root of negative 1 is I. And then the square root of 36 is 6. Now, remember, a common mistake is after you take the square root sign is gone. And then to simplify that, most students, if you get stuck there, might be like 3.75 there, is I'm going to factor out a 2. because they're all evens. So just think opposite by distributing, right? 2 times something equals -6, that's -3. 2 times something, that would be 3i over 2. And then your 2's would cancel. And then you're left with x equals -3 plus or minus 3i is your answer. Question number 9. Given x to the 4th minus x squared minus 12, factor completely. So I have a trinomial. 1, 2, 3. That's an A, B, and C. And if I can take half the exponent, let's see if we can take half the leading exponent, x to the 4th. So the 4th, half of 4 is 2. This is good when both these conditions work. You can use x box. So let's do x box. Your A, B, and C, your A value is 1, so A times C, 1 times -12 is going to be -12. And then my B value is going to be -1. Two numbers that multiply to be 12 is 4 and 3, and they need to add to be -1, so this one is going to be there, negative. -4 times 3 is -12. Add those together, you get -1. Now, let's say you don't know the shortcut. Just take those two values. They will always go there. Remember, they're splitting the middle term. So the first term will always go into the top left. The yellow here, -4 and 3, are splitting -1. So you have to add an x squared, and the last term -12. Just take out your greatest common factor, x squared minus 4, and then plus 3. And then double check by multiplying, and that works. So to factor completely, I have x squared minus 4 and x squared plus 3. But here, if you would recognize, you have to factor that one again. And that's why I drew a kind of a big space right there. If you had put a 0x here, you would have gone A times C is -4, your B value is 0, and your two numbers are 2 and -2. So to factor the red, it would be x plus 2, x minus 2. And then this one would just be x squared plus 3. What was the shortcut I was talking about before? Remember, when you're doing this x box method, you only have to do the x when a is equal to 1. If this number is greater than 1, you have to do both x and the box. So to summarize, a is equal to 1, just use the x, and if a is greater than 1, you have to use the x box. But if you forget and don't know that shortcut, you can actually do both and get the same answer. All right, second step is now find the zeros. How do I find the zeros? Well, these are called factors. I don't know, an obvious way to kind of explain that is they have parentheses. To find or identify the zeros or solve for the zeros, or just solving, I'm going to set each of these equal to 0. And then you just basically solve each one of these. Subtract 2, x equals -2. Add 2, x equals 2. Subtract 3, x squared equals -3. How do you get rid of the power of 2 there? You have to take the square root. We talked about previously, if you take the square root of an equation, it's plus or minus. And then you have the square root of -3. And the factors are -1 and 3. Square root of -1 is I. So there, this 0 is x equals plus or minus I radical 3. Again, the reason why you have to write that plus or minus is because now if you take one of these, something like I radical 3 squared, I squared is -1, and -1 that becomes the square root that becomes the I radical 3 squared would just be I radical 3 times I radical 3, which is I squared times 3, which is -1 times 3, which is -3. So that proves to you, not in the red, but if you put in positive I radical 3 or negative I radical 3, it'll equal -3. So there's two answers that you can put in for x. Squared will give you -3. Okay, sketch the graph. Sketch it. Use my straight edge. I'm going to write the original problem down here just so you can see it. X to the 4th minus x squared minus 12. Alright, so -12 is my y-intercept. Let's write -12. And it's to the power of 4, so it's an even degree like a quadratic. Starts up, ends up. Leading coefficient is positive, so your arrows stay that way. And then I'm going to take x equals -2. Let's see what colors I got. And then x equals 2. Okay, now remember this is on the x and y coordinate, so this is the real number system. So there is no I in radical 3 on the complex, so you can just go ahead and sketch it. Now I should show some kind of turning point or extrema to there. Why is that the case? Remember, the degree 4 is equal to the extrema minus extrema equals degree minus 1. We learned that previously. Extrema equals degree minus 1. So if I have 1, 2, 3 extrema, and you add 1 here, you get a 4th degree polynomial. So that basically is telling us in a 4th degree polynomial, you have to have 1 less for the extrema. So if I just went here and did a quadratic, I wouldn't have enough extrema. And then that's how you graph your, looks something like this. Doesn't look exactly, but it's a W, and you should have 3 turning points. And then for the extra credit question, what is the main, for period 2 was, who is the main rival that we have? Period 2, the answer is Magnolia. Period 3, I said the first day introduction video, what do I like? There's 4 things you could have put one of before uptake as extra credit: boba, Coke, Michael Jordan, or Pomerania's. And period 4 was my first job in high school. The answer was library or Jamba Juice.
Math.
Say it again.
Our math.